Hi and a very good day everyone. So in this video, we will be doing a very short and quick revision of SPM physics topic, which is heat. So in this topic, you need to understand pressure, specific heat capacity C, specific latent heat L, and the gas loss. Alright, so first let us look at thermal equilibrium. As you can see, this figure that has P and Q shows that two objects of different temperatures in thermal contact. So let's say in this case P has a higher temperature than Q. So when an object of a higher temperature is brought into thermal contact with an object of a lower temperature, there will be a process of heat flow between the two objects, in this case between P and Q. So as you guys have already learned, P has a higher temperature. Therefore, the rate of heat transfer from P to Q is greater than the rate of heat transfer from Q to P. As a result, there will be a net flow of heat from P to Q because there is a difference, right? P loses heat and becomes cooler, while Q gains heat and becomes hotter. After some time, P and Q will reach thermal equilibrium because they have the same degree of hotness. So, there is no net flow of heat between the two objects once thermal equilibrium has been achieved. It is simple as that. You just need to understand the concept. Alright? Okay, next, let us look at the specific heat capacity, C. What is specific heat capacity? It is the ratio of heat energy absorbed by a substance to its increase in the temperature. So, the greater the heat capacity of an object, the less the temperature will change for a given amount of added heat. While if an object has a very small heat capacity, the temperature will change a lot for a given amount of added heat. So in this subtopic, you will need to use this formula, which is C equals to Q over M theta. So Q is the heat energy in joules, while M is the mass in kg, and theta is the temperature change in degrees Celsius or Kelvin. Okay, let us look at the first example. Romney uses a 1.2 kilowatt heater to heat 500 grams of water in a beaker. The C, or specific heat capacity of water, is 4,200 joules per kilogram degrees Celsius, and the initial temperature of water is 28 degrees Celsius. We assume no heat loss. How long will it take to boil the water in the beaker? Okay, so first thing you should do before you answer a question is to understand what does it want. So in this question, it wants you to find the T, time taken to boil the water in the beaker. Okay, next, you should highlight the keywords. In this question, the keywords are 1.2 kilowatt heater, or P, power, to heat 500 gram. 500 gram is the mass of water. The C of water is 4,200 joules per kilogram degrees Celsius, and the initial temperature is 28 degrees Celsius. Okay, then only you can answer the question. So, power of heat. Power of the heater, P, is 1.2 kilowatt. We change it to watt, 1,200 watt. And then the specific capacity of water is 4,200 joules per kilogram degrees Celsius. And then the mass of water is 500 gram. So we change the SI unit to 0.5 kg. And then the change in temperature. You know that when you want to boil the water, the final temperature will be 100 degrees Celsius minus the initial temperature, which is 28 degrees Celsius. You will get 72 degrees Celsius. So, let T be the time taken to boil the water. Then the quantity of heat provided by the heater is Q equals to PT. You know that the equation of specific heat capacity is Q equals to MC theta. So, just substitute, you will get PT equals to MC theta. So, you have all this data, so you just substitute. P is 1,200, T equals to mass 0.5 times C, 4,200 times theta, the change in temperature, which is 72 degrees Celsius. So, after arranging and calculating, you will get T equals to 126 seconds. Or you change it in minutes, 2 minutes and 6 seconds. Just as simple as that. Okay, we go into the third subtopic of heat, which is a specific latent heat, L. So what is specific latent heat actually? It is actually the amount of heat required to produce a change of phase. Okay, you refer to this graph. Okay, so as you can see, when water wants to change into steam, it will undergo a constant phase, or it will take a constant temperature during this phase. So actually, when any material is heated to the temperature where it changes state, its temperature will remain the same until all the material changes state. So changing the state of the material where water changes to steam requires extra heat energy that is not used to change the temperature. So externally, you will not see any changes in the temperature, but internally, there will be changes in the characteristic of the matter of the water, where it changes from water to steam. So in this subtopic, you will use this formula of L equals to Q over M. So Q is the heat in joules, and M is the mass in the kg. Simple. Okay, let us try example 2. What is the amount of heat required to heat 2 kg of water at 50 degrees Celsius into steam at 100 degrees Celsius? Okay, as I have said earlier, you need to really understand the question. In this question, it involves two states of matter, which is water and steam. Water at 50 degrees Celsius and steam at 100 degrees Celsius. Okay, next is to highlight the keywords, which is 2 kg, the mass of water. Okay, this is the mass, and then it says water, so you know that the C of water is 4200 joules per kilogram degree Celsius. And because it involves the change of phase, so you need to have the latent heat. The latent heat of vaporization of water is 2.26 times 10 power of 6 joules per kilogram. Okay, this data you can get it from your textbook or reference book. Okay, next, because it involves two states of matter, so first we need to find the heat needed to heat water from 50 degrees Celsius to 100 degrees Celsius. 100 degrees Celsius. Okay. You use the specific heat capacity, which is Q equals to mc theta. Alright. So M is 2 times C, 4200 times theta. Theta is 100 times 50. Because there is temperature change, 100 minus 50. So you will get 2 times 4200 times 50. So you will get the final answer of 4.2 times 10 power of 5 joules. Alright, and then the second heat needed to heat water at 100 degrees Celsius into steam at 100 degrees Celsius. So you have already learned that during this phase, there will be no temperature change. It just needs extra heat to change its matter from water into steam. So 100 degrees Celsius of water into 100 degrees Celsius steam. So in this to find this Q2, you need to use the specific latent heat, which is Q equals to ml. Just rearrange, okay? So M is 2 times 2.26 times 10 power of 6. You will get 4.52 times 10 power of 5 joules. Okay, the final answer is actually the sum of Q1 and Q2. Because you need the amount of heat required, right? So just add it together and you will get 4.94 times 10 power of 6 joules. Okay, we have come to the final subtopic of heat, which is the gas laws. So there are 3 gas laws that you need to memorize, okay? So first is Boyle's law, second is Charles' law, and third is pressure law. So first, Boyle's law states that P is inversely proportional to volume. pressure is inversely proportional to the volume. So if you rearrange, you will get PV initial equals to PV final. And then Charles' law states that volume is directly proportional to the temperature. So if you rearrange, you will get V over T initial equals to V over T final. And lastly is the pressure law. Pressure law states that pressure is directly proportional to temperature. So P over T initial equals to P over T final. So if you combine it all together, you will get P1 V1 over T1 is equals to P2 V2 over T2. Just remember all this formula, okay, because you will need to use it to answer the question later on. Okay, let's try the final example. A balloon is filled with 600 cm³ of helium gas at P atmosphere, 101 kilopascal, and temperature of 27 degrees Celsius. The balloon is then released and ascends into the sky. What is the volume of the balloon when it stops at an altitude where P atmosphere is 90 kilopascal and the temperature is 10 degrees Celsius? So, this question asks you to find the volume. Okay, read the question properly and find what does the question wants. So, it needs the volume. Okay, so we highlight the keywords, which is 600 cm³. We know that it is the volume. And then P atmosphere, it is the P1. Okay, the 600 cm³ is the V1. And temperature of 27 degrees Celsius is the T1 initial. Okay, and then the balloon is then released. So the final atmosphere is 90 kilopascal, which is the P2, and the temperature is 10 degrees Celsius, which is the T2. Once you have all this data, you just need to substitute it into the formula of P1 V1 over T1 equals to P2 V2 over T2. Okay, just substitute it. P1 is 101 times V1, 600 over T1, which is 300 T1. Okay, T, make sure you change it into Kelvin first, okay? See, T in Kelvin. So, to find the T1 is 27 degrees Celsius plus 273. So, you will get 300 Kelvin. And T2 is 10 degrees Celsius plus 273. You will get 283 Kelvin. Okay, substitute this data. So, T1 is 300 equals to P2. P2 is 90 times V2, the one that you are searching, the one that you are calculating, and T2 is 283. Alright, just arrange it and you will get the final answer of 635.2 cm³. Therefore, this is the new volume when the balloon ascends. Alright, so that is all for this video. I hope you understand. Please give feedback in the comment section below and hit the like button if you like this video, okay? I just want to wish good luck to all those who are going to sit for SPM. Do your best and don't stop study, okay? Thank you.